SSH Private RSA key has been accidentally pushed to a public repo, might as well consider it leaked, because the moment anything exposed even a tiny fraction publicly, it's as if it's leaked, because it could have been sniffed. The Wayback Machine might have read it and cached it, cached that page. Someone might be reading it. So when I read that news, I asked myself, like, what does that mean? What does it mean for the private key of the SSH session that belongs to GitHub to be leaked? So I tried to unpack that and try to understand this a little bit more. And that's the goal of this episode, just to understand, what does that really mean? What is the implication? How does SSH really work when it comes to host keys and public key cryptography? So I'll try to unpack this in this episode. Let's jump into it. So this comes from github.com. Let's read a little bit and then dive into the discussion here. We updated our RSA SSH host. At approximately 5 a.m. UTC on March 24th, out of abundance of caution, we replaced our RSA SSH host key used to secure Git operations for GitHub.com. We did this to protect our users from any chance of an adversary impersonation of GitHub and eavesdropping on their Git operations over SSH. This key does not grant access to GitHub infrastructure or customer data. It's very important. This change only impacts Git operations over SSH using RSA. Web traffic through HTTPS is not affected. You know that this will happen if you get this particular message. If you connect it to GitHub and try to push something, push the commit or even clone a repo, you might get this message. For those listening on the podcast, I'm going to read this out loud. Warning, remote host identification has changed. It is possible that someone is doing something nasty. Someone could be eavesdropping on you right now, man-in-the-middle attack. It is also possible that the host key has been changed. So GitHub in this blog walks you through how to remove your old key, the old public key that belongs to GitHub, and then replace it with their new public key, because they don't share the private key, they share only the public key that matches their private key. So let's go ahead and actually discuss what all this really means. SSH works very similar to TLS when it comes to negotiation. The first step is they exchange the algorithms for the key exchange. Okay? It says, all right, I support this version of SSH, I support these algorithms, and here's my key parameters. Let's go ahead and exchange the key, right? And they use Diffie-Hellman to do that, so that both parties, the SSH server and you at the SSH client, can derive this symmetric key encryption, and then you start encrypting with that key, right? So that nobody can seize that. But just like TLS, there is the authentication part. How do I trust that the server I'm connecting to is the server that I'm connected to, and it's not an imposter, right? In TLS, we have the whole thing with certificates and certificate authority. The server will create a certificate, a public key, and then use a third-party certificate authority to sign this certificate and create a chain. And this chain is returned to the client, this full chain from the leaf certificate to the certificate authority to the root, right? And the client side will have either root certificate that is trusted in their operating system cert store, or the certificate authorities list of their public key. So if once the client receives that certificate chain, it will do a hierarchical check to check if the parent, either one of these certificate authority, is in the store or the root is in the store. If it's in the store, I trust it. If it's not, I don't trust it, and you get that error, right? In SSH, it doesn't work like that. There is no cert store. What there is there's a file called known hosts, right? in SSH, and you can go to it through, what was this, tilde.ssh / known host, and the list of the public key, the raw public keys of all the servers are there. You can go and manually add a public key that you trust. So you can exchange a public key of the server, off channel, and save it manually. That's the best approach to stay absolutely safe, right? So you can go to like GitHub and download that key and then literally just add it manually yourself to the client machine. And this way you now know and trust that server. No? So the other way is when you connect first time to a new server, it will warn you. It says, hey, I know I didn't find the server public key in any of my known host list. Do you want to add it? If you say yes, it will just add it manually. So you become, it's up to you to trust that or not, right? So this takes us to the SSH handshake. When you first connect through SSH, whether you're just directly shelling, right, or you're cloning a GitHub repo, for example, through the SSH endpoint, right? What happens is you're actually connecting to the TCP port 22 on github.com. Right? After the connection, you'll establish a SSH session, which is says, okay, here's the clients, here's my server parameter, and then the server sends you something called the host key. And the host key is literally a public key that the server has, and this doesn't change, right? This host key rarely change. And that is the identification of the server, right? So what happens is once you take that host key, which is literally just a hex of that value, you check, the client checks the known host and says, are we in this list? Yes, I trust you immediately. And then you go through the login credential, right? Now you're prompted for a password. Or if you're using public key authentication, you can exchange your public key to the server, and the server will check, is this client in my authorized keys list? Then you will log in without a password, right? That's the passwordless thing. So that's what's happened here. So now, what happened with GitHub? GitHub, the private key of GitHub always has a matching public key, and that public key shared to, I'm not exaggerating, because I don't know how long this public key was alive, but it's not exaggerating if I say hundreds of millions devices, it's everywhere. It's like every time you use a client, an SSH client, to clone a repo, you connect to GitHub, and that known host will use that old public key to store it. So, and I omitted something here that I recently learned as I researched this topic, that RSA is just one algorithm, right, to get the host key. And that is also exchanged during this negotiation, the SSH negotiation. So you can say that client, hey, I prefer elliptic curve Diffie-Hellman key, guys, if you have it. Hey, server, if you have elliptic curve, give me that key, right? But if you have only RSA, I'll take that, right? So there is, even the key can be different. So what got leaked in case of GitHub is actually the RSA key, right? So still, that thing is everywhere, right? So there are millions and millions and millions of devices whose known host have the old public key of github.com. You might say, what's the problem with that? Well, that's the question I ask myself. How bad is this? Because they don't tell you this stuff, right? If someone took that private key, right? Like with the Wayback Machine maybe has archived it, someone sniffed it and got that, because there was like a brief period of time where they pushed their private key accidentally. If someone got it, then they can create an SSH server and they can put their private key on the RSA SSH key as a host key, right? So you can place it there, right? It's literally under SSH config, right? You can put it as in the SSH server. You can put that private key. And then because you have a private key, you get the public key, right? Because there is always the private key, and the public key is known. The private key is now known. The public key was always known. You put it there, and then you are pretending to be GitHub. But there is one problem. You now have to get the second one. The first step is done. Your machine, your attacker SSH server is now done, right? It's now GitHub. It's an identical copy of GitHub. The second problem is like you have to somehow trick clients to connect to you, to your IP address, because you're not going to have github.com. It's impossible, right? So one trick is to do a DNS poisoning. While it's not trivial, it can be done. Well, if someone took the laptop, right, the development, they went to Starbucks, and you somehow, let's say you own that Starbucks router, right? And then you injected a specific entry to hijack DNS queries for github.com, and instead of just bypassing the DNS query to the recursor, to the upstream recursors, what you do is just you reply back with your attacker SSH copy of github.com, the IP address. If you do that, then GitHub now from this developer machine will point back to your server. Okay, now what do you do next? You're gonna do a GitHub clone, for example, right? You're cloning a repo, or you're doing something, you're trying to connect, you're trying to push something to GitHub. The act of git add or git pull or git push will establish a new TCP connection to github.com, but not the actual original server. It will connect to your attacker server. Nice. The next step is we're going to exchange the client SSH keys, right? The server, which is your attacker server, will reply back with the host key of the old public key of github.com, right? Your client machine has never connected to GitHub before that point. So you still have the old public key that matches the private key which got leaked. GitHub didn't get a chance to update you yet because you're one of the millions that you didn't get updated, right? And because the attacker server responded back to you with this public key, your SSH client innocently will look up your known host and will find that the public key is there, and it will completely trust you. The next thing is what? Is the authentication, is the authorization, I guess. Now you're authenticated. Now you trust the server, which is bad. The next step is, if you put passwords, then enter. You type in the password. You just leaked your password to the attacker server, because now that password will be encrypted with the symmetric key that has been negotiated between you and the attacker server. And then that password is now sent to the server, and the server will, of course, decrypt it and store it. And the server can do so many things here. The server can act like an actual Git server and forces you to push. It causes you to, hey, just push the stuff. It will just, hey, push your code. And if your code is private, that's a really disaster, because you just now pushed private source code that is not supposed to be public to the attacker server. So this is really bad. As far as that's how I analyzed it, right? I think this is pretty bad. But if you got this message, okay, which says, hey, remote host identification has changed. Now let's explain what happened here. Now nobody's doing a man-in-the-middle attack on you. You just connected to the GitHub the next time, right? What the SSH client is doing here, again, this warning, remote host identification has changed. This is the SSH client being cautious that, hey, I connected to this server, right? The GitHub pointed you to the same IP address. The server responded back with a different public key than the one you have in known host. So it looked up the github.com as a website in your known hosts, but it found that the public key that is returned is different from the public key that's stored in known host. So SSH will always throw this message like, hey, something changed. Either someone is man-in-the-middling you, right? And because that's the normal path, right? If the private key didn't leak and someone tries to do this DNS poisoning cache, they will never have the private key to begin with, right? So they will have to use a different public key. And the moment they use different public key for the same host, they will get this error. And that's where SSH client trying to be cautious, right? To give you that message. But they also tell you that, hey, by the way, it might be just that the host key has actually changed, right? And here, the good thing about this message, and I don't know how this happens, how to force the verification to fail, you know? I couldn't find that out yet, you know? Because every time I connect to a different host, I get this message, do you want to add it? No, I don't want to add it. It seems like GitHub is having an option to force the verification to fail if you ever get a different public key, which is a good thing. I'd like to have something similar there. I'll probably look it up later, but probably there is an option. Probably. So yeah, so what happened here is, ironically, is the client thought that someone is doing a man-in-the-middle, but it's not really, right? What happened is the server host key has changed, and now you need to update it. Now, the good thing about this is they tell you don't just say yes, go and actually do it manually. And the steps here is, the first step is SSH-keygen-r, which means remove anything that says github.com. Remove all the public keys that are on my known host. That's the first thing. Or it says go ahead and do it manually if you want, just edit it. And then go ahead and add this entry. That's the new public key, by the way. We're looking at the large ass public key here. And this is, by the way, it's a base 64. Because the public key is just what? It's like, it's a binary, right? And you can't really paste binary. It's not really text friendly. So you change it to a base 64, so it becomes like A B 3 N Z Z Z 1 Y C 2 A Q A B B Z. Okay, I'll stop. And then they'll say, okay, you can also automatically update the RSA SSH key here, blah blah blah. Do that. And that's just another way, right? What is affected? GitHub Actions and pretty much everything that uses automation, right? If your default preference for SSH keys is elliptic curve signature, like the other one, you're fine because that didn't get leaked, right? If you're using HTTPS, right, that's another path, right? To like you can clone through HTTPS, right? SSH is just like more. A lot of people prefer SSH because it's consistent. With HTTPS, like there's a cert store, there's sometimes you require, I don't know. I found HTTPS to be like, at least it was like 2016 when I used it. It was always like shaky, very shaky to use. But maybe it's like more stable, right? Effectively, if you're using ECDSA, you're fine. If you're using ED25511, you're fine. Does that mean, like, I want to preface this by saying that using ECDSA doesn't mean you're immune, right? It's like someone will say, oh, is this like more secure? Of course it's more secure, but this is not about security in a sense of breaking RSA. Nobody broke RSA. It's like if you took the ECDSA, the elliptic curve Diffie-Hellman signature algorithm, and you publish the private key, that's pointless, right? The security of that algorithm is pointless. You just publish the private key, for God's sake. So it doesn't matter which algorithm you use. So this could have happened to any algorithm, right? So don't think you're safe, right? The moment the private key is pushed, right, that's a disaster, right? I suppose you can argue that HTTPS is the most secure because, well, unless someone also pushes the private key of the certificate, and that's something I talked about, right? If you accidentally leak the private key of the certificate, that's also a disaster, right? All right, guys. So that's all what I wanted to talk about here. There is so much happening at GitHub right these days. Like I think they have like over 12 outages on March 2023, and I think they just laid out like 40 people from India, their entire engineering team. So there is so much happening, and wish all our engineering brethrens all the best. And something is going on, definitely. It has to do with AI probably, and there's a big shift in Microsoft and what's happening. But this could be like a significant infrastructure change that caused them to accidentally make silly mistakes like this, like pushing RSA. I don't know, like pushing the private key of an SSH RSA key. That's kind of bad. But alright, guys. So that's what I wanted to talk about. Like, I found this interesting, and to unpack this, I always like to, when I read something, I always ask like, what does that mean, right? And I rarely find the answers, so I try to find the answers myself, and I might be wrong in some of the things. So let me know if you like this stuff. Talk to you on another one. Bye bye.